So in question 5 I've been given some information about full-time workers, part-time workers and contractors, and they are F, H and C, and whether they walk or have alternative transport in order to get to work. I've got my totals, and as agreed with the question there are 200 employees altogether. So the first bit, part A, I've got to find the probability of a part-time worker, so probability of H. So I'm obviously looking at H, and there are 110 of them out of 200. So 110 out of 200, 11 out of 20, or as a decimal. In part B of the question, I've got to find the probability of F intersection with W not. So if I can find the probability of F intersection W, in other words, a worker who is full-time and walks, let me have a look. Full-time and walks is 2 out of 200. So not that must be the number of people. So 200, take away these two, so that's 198 out of 200. Out of 100. Part C, a conditional one. As soon as I see my slash bar there, I know it's conditional. So I'm given the fact that C has already happened. So my laws of conditional say I need to get the intersection divided by C. So W intersection C means walking and a contractor. So walking and a contractor is 30 out of 200. Divided by the probability of being a contractor, so altogether there are 80 out of 200 contractors. In other words, we've got 30 out of 80. In the last part of the question, part D and part E, I'm given some more information, and I'm given some information that there's a bus, and some of the people get a bus to work. So I'm looking at drawing this situation on a Venn diagram. I'm labelling B for bus, and I'm thinking, well, there are a mixture of people getting this bus. There are full-time workers, there are part-time workers, and there are contractors. You can't have an intersection of those three sets because they're either one or the other of those, but potentially they could all get the bus. And I'm putting some information in my Venn diagram. So it says 10% of full-time workers use the bus. So this amount in here, the intersection, 10% of full-time workers use the bus, must be 10% of the number of full-time workers. Well, there's 10 full-time workers, we found that earlier on. 10 full-time workers. So 10% of 10. That must be one person in there. I'm doing the same thing here. Read the information. I've got 30% of part-time workers use the bus. So 30% of part-time workers use the bus. So that's these guys here. People who are part-time and use the bus. 30% of part-time workers. So 30% of 110. So I want 33 people in there. Now let's look at the contractors. What percentage use the bus for the contractors? It says that 20% of contractors use the bus. 20% of contractors, 20% of 80 people is 16. So that's 16 in there. So I'm beginning to get my Venn diagram together. What else do I know? I know that there are altogether 10 full-time workers, so that's on the outside circle, so that there must be 9, because the 9 and the 1 make the 10. I know for part-time workers that there are 110 altogether. So in terms of the area here, for part-time workers, I've got 77. And for contractors, I know that there are altogether 80 contractors. So I must have 64 there. So I've got all my pieces in the Venn diagram labelled. What else do I need to do? I need to see if there's anybody outside. Well, they've got to get to work somehow, so they must be somewhere in there. So I'm assuming that everybody adds up to 200 people. And I can check that, but it does. Everything does there, add up to 200 people. So, my question is, draw a Venn diagram to represent the events F, H, C and B. Done it. E. Find the probability that a randomly selected employer uses the bus to travel to work. So uses the bus to travel to work. So how many people use the bus to travel to work? They must be everything in here. So we've got 1, 33 and 16 people use the bus to get to work out a total of 200 people. So 1 plus 33 plus 16 out of 200 people must be what I want. So that's a quarter.